We start by talking about one of the simplest norms, called the Frobenius norm. Now, to motivate it, what I'm going to do is I'm going to link how matrices are stored in memory to vector norms and then back to the Frobenius norm. So, a typical way in which matrices are mapped to memory, let's see, what's the problem here? A matrix is a two-dimensional array of numbers. Memory tends to be linear. Is to say, we'll store the first column of the matrix first, and then we'll store the next column of the matrix, and then the final column of the matrix. And that's known as column major order storage, or column major order storage. Okay, well, computing a norm of these numbers, you can take your pick of vector norms. And the 2 norm is a nice norm. So, we could say, to measure the magnitude of this matrix, we will simply think of it as a vector of numbers. And then we can compute the 2 norm of that vector of numbers. And with that, maybe we end up with a norm. Now, it would be tempting to call that the matrix 2 norm, but it turns out we're going to use the term matrix 2 norm in a slightly different way. And this is then actually called the matrix Frobenius norm. Frobenius. Okay, and what is it? It's just the sum of the squares of the absolute values, and then you take the square root of that. Okay, so it's the square root of 1 squared plus minus 2 squared plus 0 squared plus minus 1 squared. Well, you might even want to put it over here. Minus 1 squared plus 3 squared plus 2 squared plus 1 squared plus minus 1 squared plus 1 squared. Square root. All right? Very simple. Now, you would think that if we think about the numbers as a vector, then we get a norm, that would then automatically mean that the Frobenius norm is a norm indeed. And we're going to let you work that out.